In this lesson, we will examine some techniques for solving basic equations. These techniques are a consequence of the following observations. Notice what happens if we begin with two equal values and then subtract 3 from both sides of the equation. When we do this, we get equal values on both sides. Similarly, if we multiply both sides by 4, the two resulting values are still equal, 20 and 20. If we add 7 to both sides, the two resulting values are still equal. If we divide both sides by 3, the resulting values are equal. And if we take the square root of both sides, the two resulting values remain equal. These observations tell us that if two values are equal, they will continue to be equal if we perform the same operations to both sides of the equation. We can take this fact and formulate the golden rule of equation solving, which says, what you do to one side of the equation, you must do to the other side of the equation. We will use this rule a lot to solve a wide variety of equations. So let's see how it works. If we want to solve this equation, our goal is to find the value of x that makes the equation true. To find the value of x, we need to isolate x. At the moment, we have x plus 5. So to isolate x, we need to eliminate the plus 5. We can do this by subtracting 5 from both sides of the equation. When we do this, we get x on the left-hand side of the equation, and we get 3 on the right-hand side. So the solution to the equation is x equals 3. Now, how do we know that this is the correct solution? Well, we can plug 3 into the equation to see that x plus 5 does indeed equal 8. Okay, here's another question. In this equation, we have 4 times x. To isolate x, we must divide both sides of the equation by 4. On the left-hand side, we have 4x divided by 4, and this is equal to x. On the right-hand side, we have 20 divided by 4, which is equal to 5. So the solution here is x equals 5. Okay, let's keep practicing. Let's first eliminate the minus 9, or negative 9, from the left-hand side by adding 9 to both sides of the equation. When we do this, we are left with 2x on the left-hand side, and on the right-hand side, 13 plus 9 is equal to 22. From here, if we divide both sides by 2, we get x on the left-hand side, and we get 11 on the right-hand side. So the solution to this equation is x equals 11. Here's another one. In this equation, we have x on both sides of the equation. So let's first move all of the x's to one side. One way to do this is to subtract 3x from both sides. When we do this, the 3x on the left-hand side is eliminated, leaving us with 10. On the right-hand side, we get 5x minus 16. From here, we can move the constant terms to one side by adding 16 to both sides. When we do this, the negative, or minus 16 on the right-hand side is eliminated, leaving us with 5x. On the left-hand side, 10 plus 16 is equal to 26. At this point, we must divide both sides of the equation by 5 to get x equals 26 over 5, which we can also write as x equals 5.2. Okay, one last equation. Here, our first step will be to expand both sides. At this point, we can move all of the x's to one side by first adding 10x to both sides. When we do this, we get negative, or minus 2 on the left-hand side, and we get 8 plus 8x on the right-hand side. From here, we can move the constant terms to one side by subtracting 8 from both sides. When we do this, we get negative 10 is equal to 8x. At this point, we must divide both sides by 8 to get x equals negative 10 over 8, which can be simplified as x equals negative 5/4, or rewritten as a decimal to get x equals negative 1.25. Okay, that should be enough to get you started on equation solving. Remember that when you are solving equations, you must follow the rule that says what you do to one side of the equation, you must do to the other side. In other words, our goal is to isolate the variable by performing the same operations to both sides. Finally, it should be mentioned that the solution to an equation is the same as the root of an equation, so just know that both terms here can be used interchangeably.